Hello and welcome to the random variable video examples. So this is all about discrete probability. And with discrete probability, we identify the breakdown in particular situations by filling in probability trees and then calculating means and such from that information. So the probability model below describes the number of repair calls that an appliance repair shop may receive during an hour. Let y equal the number of repair calls that the appliance repair shop receives in an hour. And we see that we have 0, 1, 2, or 3 calls with the 10%, 30%, 40%, or unknown percentage in probabilities. So we can see that for us, in order to find the missing probability here, it's just this needs to sum to 100% down here. So if this totals 80%, that means this right here has to be 20%. And oh look, the very first question, find the probability that the repair shop receives 3 calls in an hour, is the very first question. To notice our new type of notation here, y is the random variable, y equals 3. Again, shortcut notation, which I could also, of course, just write out the full sentence, but y equals 3 is the shortcut notation, which is 20%. And I mean, if you want to do the calculation, 1 minus 80% as well. One of the biggest questions regarding discrete probability distributions is, like everything, is looking for centers and spread. In this case, the mean. Whenever you see the word expect, that's really that means we're looking for the mean. The difference is that with this, it's a weighted average. Instead of just summing all the values up and dividing by the total, like we're used to, each value has a weight associated with it. So you see, 0 occurs 10% of the time, 1 occurs 30%, 2 40, and 3 20%. So in order to do the calculation, the notation, mu, the mean, equals the expected value of y, which is the sum, this big sigma just means sum, of each value times its associated probability. 0 times 10%, plus 1 times 30, plus 2 times 40, plus 3 times 20. Calculate that. So basically, you're taking each value and multiplying, and every time there's a space, you sum. Then multiply, sum, multiply, sum, multiply. Get that out, and the important thing here is make sure you attach your units. 1.7 calls, right? Expected number of calls in an hour. Again, in order to save us time, I've also done this calculation for the standard deviation. Standard deviation is slightly more complicated because in order to find the standard deviation, that's the square root of the variance. In order to find the variance, that is the expected value of y squared minus the square of the expected value of y. So what we need, we've already found the expected value of y in the last problem, it was 1.7. You need to calculate e of y squared, which is almost the same calculation. It is each value squared times its associated probability. So 0 squared times 0.1 plus 1 squared times 0.3, etc. And I don't put units on this because it doesn't have an interpretation. The units would be calls squared, but it doesn't have a good interpretation, so it's just a means to an end. Once you have that 3.7, then you plug that in, minus 1.7 squared that we found in the previous problem, gets us 0.81 calls squared. Again, this does have an interpretation because variance is used to calculate standard deviation, so we do put the units on this one. Then you square root the 0.81 to find the standard deviation, which gives us 0.90 calls squared. This, all right, is very, very helpful because every time when we're identifying information, you find a center and a spread. This means I'm able to calculate both the mean and the standard deviation here. From this, we can then answer even more interesting questions. So, if each call makes the shop $100, find the expected revenue to the shop. Well, that means the revenue is actually 100 times Y, the number of calls. And expected values work exactly how algebra has taught you they should work. If you have a value that's 100 times Y, that means all you have to do to find the expected revenue, which I'm going to call E of R, that means that's E, the expected value of 100Y, which means that is 100 times the expected value of Y, which is 100 times 1.7 that we found previously, which gives us $170. So, and again, logically, I could have done this from the beginning. Oh, $100 per call on average, that's just 100 times 1.7. So I could have jumped immediately here, right? I did that step by step so you could see when we identify standard deviations, right? Standard deviations or variances. So for variances, it does not work the same. It's not just purely multiply the value across. If you want to find the standard deviation, you first need to find the variance. The variance of the revenue, which is the variance of 100 times Y. Variance rules work much differently. You don't just pull that 100 out and square it. You pull that 100 out, or sorry, you don't just pull that 100 out and multiply it. You have to pull that 100 out and square it. Because everything with variance is squared. It is what's known as a bilinear operator, which means it reacts different than all the algebra you've ever done in your life. And it has to be treated specially. Once I have that, then I can multiply by the 0.81 that we found previously, which then gives us $8,100 squared. Then, in order to find the standard deviation of the revenue, you could take the square root of the variance of the revenue, which is the square root of 8,100, which gets us $90. So you have to make sure that you follow the rules of variance. This is even more clearly shown if I was to give you a slightly more complicated problem. The variance of 2x plus 5. Whenever you have values being added, you have to drop them with variance. The variance of a constant is 0, which means this becomes the variance of just 2x. Then, just like we did before, that 2 is pulled out and multiplied, which actually gives us 4 times the variance of x, whatever x may be, or variance, whatever the variance of x may be in this situation. But notice, all right, if you were doing expected values, if I was doing the expected value of 2x plus 5, this works exactly how I think it's going to work. This becomes 2 times the expected value of x plus 5. It's exactly how we've been taught algebra works all along, because this is a linear operator. However, variance is different algebra than you've ever done. So you have to follow the rules of variance from the lecture. All right, so lots of interesting stuff with discrete variables. I hope that was helpful, and have a good day.